Last time we started chapter 2, and we talked basically as I started was like that. In chapter 2, we have the circuit that's all is made of resistance and sources. That's all we are going to have, and we look at them how we can analyze them. But eventually, at the point we came, and then later on, what we learned last time is that if we can find a resistance in series or parallel, we can combine them and find the equivalent one. And then by combining them, we simplify the circuit in a point that we could get a very simple circuit, and we start to analyze it. And that is should be if you are given a circuit and you're not given any specific method to use, that's probably your best bet to look into the circuit and see if there is any parallel or a series resistance, and combine them and try to make a simple circuit, and then based on that analyze. Unfortunately, there are, I would say, majority of circuits we are going to see, you cannot find any series or parallel elements into that, and you cannot use that method. They might have 2-3 elements that are a series and parallel, but you cannot simplify the entire circuit to the point that you can get a simple circuit and start analyzing it. Still, after you combine all the series and parallel together, still you are going to have a complicated circuit. And in some cases, you may not even have any, let's say, any parallel or series elements in the circuit at all. So the next method that we are going to use, the next two methods, and today we start from one of them, is for more general cases. It doesn't matter how the elements are arranged in the circuit, we can use it. So it's more powerful from the previous method, and it can analyze almost any circuit you give it to it. But at the same time, because it's more powerful, it's more complicated and needs more steps, and sometimes it might not seem very straightforward to work with that at the beginning. So the very first method that we are going to start to talk about it is called node voltage method. Oops, so up. So assume we have a circuit like this, that I have a source sitting here, and then it goes up, then I have a resistor, then I have a node, and then it's going to come there. Resistance here, then there's a node, and then I have another resistance here, node here, another resistance here, comes like that, then there's a node here, comes resistance on top, like this. So if you look at this, and I'm going to just R1, it's going to be R1, R2, R3, R4, R5, and the source. If you look at this, if you have something like that, basically in this system, we don't have any of these elements in parallel or series. If we are given a circuit like that, we can't do anything. We cannot simplify it further than it is. It is gonna stay like that. And because it's stay like that, we cannot use any of the previous method we talked about it. We cannot simplify because they're parallel. We cannot simplify because they're series. So this is the whole circuit, and we have to start analyze the circuit as it is like that. I will go ahead and tell you when we want to start analyzing. First, I will tell you what we are going to do, and then I will show you how to do that. The very first step when we start to analyze a circuit is that we have to choose a reference node. So let me go and name the node. So first, I will name the node. So I assume I have this node here. I assume the voltage at that node is V1. The voltage assumed at this node is V2. The voltage at this node is V3. And then I have to choose, so I said it's the 1, 2, and 3. The very first step is to choose a reference node. And most of the time, if you have the source in the system, it's better to choose the reference node that is connected to the source. It just simplified it simplify what you are doing, but not necessarily. In other words, you can choose any of the node in the circuit as your reference, but try it if you have a node connected to your source, try to use that one as a reference. So we can choose this node as a reference. I'm just going to draw it a little bit different as the book does it, but the book says, okay, I choose the reference node here. And since there's only wire between these nodes, so these two nodes are the same, so they behave the same. So I could have choose this, the reference node as that and put the ground sign right beneath that. So, but just to follow the book, I put it a little bit further away. So it's the same thing, even if I put it here. This is the ground sign. So it means that this is my reference node. I assume this is my reference node. And when I assume the reference node, my reference node has two, I would say, characteristics. First, my reference node would be negative. I would consider it negative compared to other nodes. So if this is the reference node is negative, this is going to be positive. We compare to the reference node, the V2 is going to be positive compared to reference node. The V3 is positive compared to reference node. So this are the second is that when I calculate the voltage difference between two nodes, I always consider the voltage here as reference as 0. So first, the sign of the voltage is negative. So when I calculate the voltage difference, consider the voltage at reference as 0. And I will show you that when I do the example. So first, one up to here. First, choose the reference node, any of one you want to choose. After you choose a reference node, the reference node is negative. The other nodes are positive. Then draw the. I will draw it with. Say. After that, draw. Let's see this go. Draw the current. Assume the current at all the current at each node leaves the node. So after that, draw the current. So I draw it here. So I assume the current here leave the node. There are 3 currents leaving this node here. Then here, there would be 3 current leaving this node like that. Let me put them all on one side so it's going to be easier. So it's going to be positive, and then so assume all the currents leaving that node also. The same here, assume all the currents leaving that node. And we don't need to be worried about that. The one that is not right would comes out at negative. So this is what we are going to do after that. Then for each node, we will write the basically the Kirchhoff current law. So for each node, we write the KCL. So for example, we write the KCL at 1. So we write the KCL at this one. Remember when I would say the Ohm law, what was the Ohm law? If I have the Ohm law, it would say that if I have, if there's a R here and it has the VR and the positive and the negative, and then I go through that, the Ohm law is telling us that V is equal to IR. And then therefore, in this case, so it's a VR, it's IR. And therefore the I is just VR divided by, what's that, the VR divided by R. So this is the current we have here. Now, when we are talking about the node voltage, and remember this, the one I'm gonna write it for the node voltage, is that if I have I will call it, for example, here V1, and then I have V2, and then there's a R here. Let's put it VR here, and then there's a I going like that, and it's a positive and it's a negative. Let me draw the line here so if this is what we have, it's always like that. This is gonna be always like that. The difference between V, if you want to find the VR is the difference between V. So the VR here is just the V1 minus V2. So I have a V1, I goes from V1 to V2, then VR is the difference between V1 and V2. The same if I have if it's a V1, and then there's a source that's going to be Vs, and it goes to V2, and then we have the I going like that. Same here. Here the V1 plus Vs is V2, and the third condition is that if we have as a positive, negative, again we have V1, V2, and then there is a I going in this direction, and this is the Vs. V1 minus Vs is V2. So these are the three conditions we are going to have when we are dealing with. And right now I'm gonna use this very first one. So look at here, the VR is the difference between V1 and V2. So if I put this in this equation, if I replace this in this equation, it's gonna tell me the I is gonna be V1 minus V2 divided by R. If I put this here, let's substitute VR from here, the I is gonna be V1 minus V2 divided by R. This is how we are gonna write the KCL for every node in these conditions. So I'm gonna write it, for example, here for the very first one. So draw another one here. So here, if I want to write the KCL for the first node at 1, so I'm looking for this I that goes up, that go from 1 to 3. The I goes from 1 to 3. Look at here, the I, here I have, let me write it incomplete so it make it easier for you. So this one, the I goes up, is the I goes from 1 to 3. This one is the I goes from 1 to 2. And this one is the I goes from 1 to, let's put this as 4. Goes from 1 to 4. Oops. That we have it. The same here. For example, here is, now look at it, is the I goes from 1 to 2. Here is the I goes from 2 to 1. Here's I is goes from 2 to 3. And here's the I goes from 2 to 4. And the same here is the I goes from 3 to 1. Here's I goes from 3 to 2. And here's I goes from 3 to 4. So this one is I goes 3 to 4. Now if I want, let's write it, for example, for 2 is for it's easier for beginning. So if I want to write it for the second one at the 2 here, the KCL is what it says, the I to 1 plus, assume everything is leaving and doesn't matter, so you just add them together. So all of them should be 0. So I 2, 3 plus I 2, 4 should be 0 because everything is leaving. If everything is leaving, if I add all of them together, it should be 0. And this is what the KCL says. And because all of them are leaving, all of them are going to have the same sign. So you can have all of them as negative or all of them as positive. It doesn't matter. It's just easier to write it this way. Assume this one plus this one plus this one, because all of them is leaving, should be 0. Now look at this equation here. I'm going to write this equation for each of them, for each of these equations. So I start from I2 to 1. I2 to 1 is going to be V2 minus V1, V start minus end, start minus end. So it starts at 2, end as 1. So 2 minus 1. And what is in between is R2. So this is the I2 one. Then I go to the I2, 3. Start minus end, start minus end. So it's going to be V at start is V2 minus V at end, V3. What is in between is R3 plus I2, 4, I2, 4, start minus end, start from V2 and at 4. So it's going to be, start as 2 is going to be V2 And the V4 is 0. Remember, I said that when we are doing the difference, the voltage at reference is 0. So this is going to be 0 here. And what is in between is R4. And it's going to be 0. So this is how it's going to be is written for the second one. So I'm also going to write it for the as a sample. I'm going to write it at KCL at 3. So if we write it at 3, you would see that again I would have the 3 of these leaving is going to be 0. So it's going to be I31 plus I32 plus I34 is 0. So the KCL, all of them that's leaving, just add all of them together. Since all of them are leaving, I just choose the same sign for all of them leaving, add them together, so it should come 0. Again, now I want to write for the 3, I31. So I31 is the V at the start minus V at the end. So 3, 1 goes from up here. So it's going to be V at the start is V3 minus V at the end is 1. And what is in between is R1. Then plus R32 is a start minus end. So it's going to V3 minus V2. And what is in between is R3. And then 3, 4, again, a start minus end. A start is V3. And at the end is the reference node. So the reference node is 0. You just put 0. And what is in between is R5. Is 0. And we can write it for, this is the simple one for 2. I write it for 2 nodes, and then in the example, we'll see how actually we use them. And for as many nodes as we have in our circuit, we are writing all these equations. And at the end, we are going to have multiple equations and multiple unknowns. And then we solve them simultaneously together to find all the unknowns. As soon as we have all the V, as soon as, for example, if I find V1 and V2, then I can calculate the I21. The same. After I find all the V's, I can go and find all the I's. So after all the voltage is known, then all the current also is going to be known. In most cases, when we do analyzing, because the I and V is directly related, when we find the V in the problem we have, most of the time they don't ask us to go and recalculate the I, because just simply substitute this equation. So this is how we actually do the node voltage method. I will give you an example, and the example is going to be much easier, and you will understand how it works. But one more time, I go very quick over the whole things that happen. So choose the reference node. This is the very first step you're going to do. Choose the reference node. And after that, you choose the reference node. Every other node, consider every other node is positive. Then assume all the currents at each node leaving that node. Assume all the currents leaving the rest of the nodes. So you choose one as a reference, then go to the rest of the nodes you have. Assume all the currents leaving the nodes. And then write the KCL for each of those nodes. It means that just add all the currents leaving the nodes, and it should come as 0. And then replace the current, each current with the Ohm law that we have it here. Just replace each current with the equivalent Ohm law. Then you are going to have a bunch of equation that has only V in them. And then you have to solve all these equations together. And when you have when you solve them together, it will tells you it gives you the voltage, and then if you need, you can go back and from each of these equations go back and uh, calculate the corresponding current for that uh, nodes or for that current. So this is the very, I would say, um, simple steps of what we are doing in the node voltage method. After we start to look at some examples, it's going to become a little bit easier how we are doing that, but this is how we do that. Okay, now let's look at an example, see how we actually can use this method. So let's start with the simple example here. So we have a current source that has IS in it. Oops. And there's a two, and then we have a resistor here. We have another resistor here, and we have resistance here, and this. So assume this is what we have and we want to solve them, and I'm going to just call this the R1, R2, R3, R4, R5. So assume this is what we have, and we want to use the node voltage method to solve this problem. And for this example, we just do everything as a parameter. We don't use any values in them. And then for next examples, we'll start to actually have some values instead of in place of the resistance and current. So this is what we have. I want to write a node voltage method for that. Basically, we are given this circuit and we are asked, okay, analyze that circuit, find all the voltage and current in this circuit. And as you can look at it again, we cannot do any of the previous method we cannot simplify this circuit further as it is. So the very first step is that if we are doing the node voltage method is to choose a node as a reference. And here, again, I said we can choose any of the nodes, but I would do that. If you have this node close to the source, to the battery, particularly the voltage source, try to choose that. If not, try to choose the one is at the very lower end. Otherwise, don't worry about it. You don't need to be worried about which one you choose as a reference. The only thing is that when you write the voltage equation, you consider the voltage at that node is 0. So it doesn't matter I choose this one or choose this one or this one or this one as a reference, but just to follow the books, I choose this one as a reference. So choose this node down here as a reference. To start. So it's a very starting point. After that, so I know that this is going to be negative. So this node is going to be negative. And every other node I have is going to be positive. So this one is going to be positive. This one is going to be positive. This one is going to be positive compared to this one. And then I would consider the voltage at each of them. So this one is going to be, I would say, it's going to be the V1. I name these two as a V2 and name this one as a V3. Remember that when I said this is positive respect to this one, it doesn't mean that V1, V2, or V3 are positive. They might come out as negative. So don't get confused about that. This positive sign is just respect to this negative sign. That's it. Nothing else. And then after that, I assume all the currents, I assume at each node, all the currents leaving the node. So I would go ahead and says here, I have the current leave that node and it's going from V1 to V3. So it's going to be I13. So I13. Then I have this one is the I12. And then I have this one which goes I from 1 to 4. And assume this, the node down here is the fourth one. Same for the middle here. So all the current assume is leaving. So it goes from 2 to 3. It goes from here from 2 to 1. And then 1 goes down here from 2 to 4. And the same here, the 1 goes from 3 to 1, 3 to 2. Goes from 3 to 2. Here it goes from 3 to 1. And so go 3 to 1. And this one is going from 3 to 4. After that, after I draw all the currents leaving each node, I will start to write the KCL for each of nodes. So I would write the KCL at 1. It means that all the I at that node, all the current goes through that node and leaves that node should be 0. So if I add all the current in that node, it should come 0. So it says that I12 plus I13 plus I14 is 0. And later on, when we get comfortable, we just skip this step. We directly start to write this part. So I12 is the voltage from start minus voltage at the end. Voltage at the start minus at the end. So 1, 2. 1, 2. Start is V1. End is V2. And what is between V1 and V2 is R2. Then I go to the I goes from 1 to 3. And if you look at here, look at this one. If I want to go from V3, I can write it V1 minus V3, but there is no, I would say, what is that? There's no resistance between V1 and V3. But the good is that we already know the I going from V1 to V3 is IS because it's given. It's the source here. We know that in this one, in this wire up here, the current is, the current in this one is IS. We know that because there's a source here that push the IS in that wire. So in other words, the I13 is equal to IS. The I13 is going to be the same as IS. So instead of I writing it, I just replace it with IS, and it's known. So this IS is known because of the source we have. When we have the example with numbers, so you have a number for that IS. So this is the IS. And then we go to the I14. I14 is going to be plus, again, start minus end. Start voltage at the start is V1, voltage at the end, because the reference point is 0. And between them is R1. So it's going to be R1. And then it's going to be 0. The same I can write it for the KCL at 2. I can write it here. So here I have I 2, 1 plus I 2 toward 3 plus I goes from 2 toward 4 is 0. So for I going from 2 toward 1 is V2 minus V1. Voltage at the start node minus the voltage at the end. So it's going to be V2 minus V1. And what is in between is R2. So if you look at compare these two terms, you will see this at the top is exactly the opposite of the negative of what we have in the bottom. So don't worry about them. You always write it from voltage at the start minus voltage at the end. Then we have the 2 toward 3. So it's going to be V2 at the start minus V3, which is the voltage at the end. And what is in between is R4. And then goes 2 to the 4. Go 2 toward the 4. So it's going to be, again, V2, the voltage at the reference is 0. And what is in between is R3. This is going to be 0. And then we come to the third point. This is going to be the KCL at 3. Again, we add all the current at that node and it should come 0. So I 3, 1 plus I goes from 3 toward 2 plus I goes from 3 toward 4 should be 0. Therefore, so again, look at here. The I goes from 3 to 1. If the look at the I goes from 3 to 1, the I 3, 1, we already know the current in this wire and we know it's the IS. And the I 3, 1 is drawing in the opposite of IS. So the I 3, 1 is drawing in the opposite wire. And we already know the IS is the current in this wire. So it's going to be negative IS here. So I 3, 1 is going to be negative IS. Then I goes from 3 to 2. Again, it's going to be 3, 2. So it's a start minus end. Sorry. Minus end. And what is in between is R4. And then we have going from 3 to 4. So it's going to be V at the start, which is 3. V at the end is 0. The voltage at the reference is 0. And what is it being is R5. And it's going to be 0 for what we have here. Now that we have these three equations, for this case, we can say that we have three equations and we have three unknown, V1, V2, and V3. IS is known, R1, R2, R3, R4, and R5 are also known. So IS is known, all the R are known. So on the unknown are V1, V2, and V3. So we have three equations, three unknowns. And when we have the three equations, three unknown, we can use the calculator or we can use the computer to solve, actually, I would say, to implement, to put it in your calculator, to punch in your calculator. And then after you do that, you get the result. Next, I'm gonna just very briefly tell you how to, if you have simultaneous equation, how to write them and how to put it in, how to rearrange them in order that you can put them in the calculator. But okay, now assume these are the three equations we have, and I want to somehow to put them in a calculator to use them. The very first thing you have to do is you have to write them as you have to get the V1, V2, and V3 and write them as that form. So the very first one, I will first look at the V1, and I keep the V1, and every coefficient I have for the V1, I put it in front of that. So here is 1 over R2, and then it's the V2 is IS, and here I have 1 over R1 plus 1 over R1. So that is the V1. So it's the V1 over R2, V1 over R1. Then I go to the V2. For the V2, the only thing I have is negative 1 over R2 times V2. And then for the V3, I don't have, so I put 0. I don't have anything for V3. I put 0 for V3. And all the other things that is not V1, V2, or V3, I take it to the other side of the equation. So it's going to be the IS, I will take it to the other side of the equation. It's going to be negative IS. I will do the same thing for the second equation. So here, for the V1, again, I have negative 1 over R2 and then I have 1 over R4 and then I have oh, sorry, made a mistake here. So for the V1, here I write it here. The V1, the only one I have is the negative 1 over R2. So I don't have any other V1. So it's going to be negative 1 over R2, and it's going to be times V1. Then for the second one, so it's going to be V2. For the V2, I have to 1 over R2 here. 1 over R2, and then I have here again 1 over R4, and I have here 1 over R3. And it's going to be times V2. And for the V3, I have negative 1 over R4 times V3. So I have 3V2, 1V1, 1V3, and nothing else. That's going to be 0. And then for the last one, again, I start with the V1. I don't have any V1, so I put 0 V1. 0 V1. Plus, for the V2, I have only one term here. It is negative 1 over R4 V2. And for the V3, I have two terms that has the V3 in this. So it's going to be 1 over R4 plus 1 over 5 R5 V3, and everything else that's not V1, V2, or V3 should go to the other side. So that negative IS should go to the other side and becomes IS. Now I have three equations here. So here you can look at them. So I have three equations and three unknown. So I have the system of equations. So V1, V2, or V3 are unknown, and R1, R2, R3, R4, and R5 are known. The IS is known. So three equations, three unknown, and I'm gonna write that I can solve them. So the next thing I can do is that I can go and put them in the matrix format which the calculator wanted. So first I put the matrix, and the only thing I keep in the matrix is the coefficient. So the coefficient in the first line, so the very first one is 1 over R2 plus 1 over R1. Then the second coefficient is negative 1 over R2. And the third coefficient is 0. That's why I use the 0 and don't skip the 0. The second line, I write just the coefficient of V1, V2, and V3. The coefficient of V1 is negative 1 over R2. The coefficient of the V2 is 1 over R2 plus 1 over R4 plus 1 over R3. And the coefficient for V3 is negative 1 over R4. And then the third line, just coefficient of V1, V2, or V3. So it's going to be 0 for the V1. So it's going to be negative 1 over R4. And it's going to be 1 over R4 plus 1 over R5. So this is going to be the coefficient matrix. Then the next matrix is the unknown matrix, the matrix of unknown, which is going to be V1, V2, V3. And then you have the constant matrix, which is going to be negative IS, it's going to be 0, and it's going to be IS. So if you look at, I'm going to just draw the line here. So here in the matrix, we have the 3 by 3 matrix. Maybe use another colors. No. So we have the 3 by 3 matrix. Just let's see what color we might use. Yes, better. So you have a 3 by 3 matrix. So it's the first columns and second column and third column. So it's the first row, second row, and the third row. And what you can here, so this is the coefficient of V1. This column here is the coefficient of V1. This column here is the coefficient of V2. And this column here is the coefficient of the V3. So this is the first row I have here, the second row I have here, the third row I have here. V1, V2, V3, and these are the constant. So when you put it in your calculator, the calculator asks you, when you have the 3 equation, 3 unknown, first your calculator asks for these coefficients. So you put these coefficients exactly in the same order here as the coefficient of your unknown. In your calculator, it might be X, Y, Z, depend on how they name it, or they might name it X1, X2, X3, I don't know. Most often they call it X, Y, Z. So these are the coefficients matrix that you enter them. These things, your calculator assume it, as I said, is most often assume that X, Y, Z. And then your calculator asks you to enter the constant coefficient, which these are the number you are going to enter in your calculator. And then when you solve it, it's going to gives you the V1, V2, and V3. Now let me write it in more general format, so you know that how you can write it. In general format is like that. So if I have, as I write it for 3 equation, and it's gonna be correct if you have 2, 3, 4, and any number of equations. But I start with the 3. So if I have the A1x plus A2y plus A3z is equal to, I would say, C1, Then I have the A2x plus, sorry, yeah. Then I have A4x plus A5y plus A6z is going to be C2. And then I have A7x plus A8y plus A9z is equal to C3. So assume I have the sets of equation like that. What I can do is that I can write them in a matrix format as this. So I can go, that's the coefficient matrix is going to be A1, A2, A3, going to be A4, A5, A6, it's going to be A7, A8, A9. So this is a coefficient matrix. Then I have the unknown matrix. For this case, is going to be X, Y, and Z. And then I have the constant matrix, which is going to be C1, C2, and C3. And if you want to punch it in your calculator, basically you put these as this A1 through A9 as a coefficient in your calculator. X, Y, Z is your calculator, assume it as an unknown, so you don't need to do anything for this. And then on the other side, when they ask you to put the constant coefficient, you put C1, C2, and C3. And then your calculator solve it, and then it gives you the X, Y, and Z for you. So whenever you have, when we are doing them, particularly in this node voltage method, you have to write your equation eventually like that. So depending on how many nodes we have, we might come up with 2 equations, we might come up with 3 equations, we might come up with 4 equations. So it's the very same things. You can do that and then rewrite it like that and then punch in your calculator. For example, if you have 2 equations, I said if you have 2 nodes and we come up with only 2 equations, I'm just going to write it on the next here. So let's see what happened, just as an example. So if I have 2 equations, it's going to comes out something like that: A1x plus A2y is equal to C1. Then you are going to have, for example, A3x plus A4y equal to C2. If you have only 2 nodes, it's going to come out something like that. And then your coefficient matrix is going to be 2 by 2. It's going to be A1, A2, A3, A4. And then your unknown matrix is going to be X and Y. And your constant coefficient is going to be C1 and C2. The same if you have 4, 5, doesn't matter, as long as you rewrite them as that, and then you need to just put it in your calculator, and your calculator gives you the X and Y values.